section, and in this section I'm going to talk about the queuing problems from data modeling and simulation. So these are different single channel queuing problems that is there in the data modeling and simulation from chapter 2 in the queuing single channel queuing. So first we'll try to understand the question, and I will try to solve the problem based on the question and based on the given parameters. So grocery store has one checkout counter. Customer arrive at this checkout counter. For the customer, the arrival times are 1 to 10 minutes apart, and each arrival has the same probability of occurrence. Whoever is arriving, they are having the same probability of occurrence. So for first customer it's 0.10, second customer it will be the 0.10. That is what. And the service times may vary from 1 to 6 minutes apart. So service times, the probability of the service time from 1 to 6 minutes or 0.05, 0.10. Assume that the first customer arrive at time 0. So the first customer that is going to happen is at 0.0, 0, and the random digits of arrivals and the random digits of service time have been given. So we'll first try to draw two tables, the inter-arrival times and the service times, and that from that we have to find simulate the arrival of 5 customers and calculate the average waiting time and the probability of the customer has to wait and probability of the server being added, and depict the simulation in a tabular form. So first we'll try to understand how to calculate the arrival time, inter-arrival times and the arrival times and all the different kinds of things. So first I will start the solution, and first thing is time between arrivals. So the arrivals and the probability of occurrence that you can start either from 1 or 0. So that is what it can be. See, the first inter-arrival time will always be 0. So first what I will do is time between arrivals. So I will create a table. So insert a table with I think so 4. Let us start with 4. Yeah, the first one is time between arrivals. And the second one is probability, and the next one is cumulative probability, and this one next one is a range of random range of the random numbers. The first one, time between arrivals, is 1, and let me just. So we have seen up to 10 time between arrivals. So 1, 2, 3, 5, 6, 7. Let me add few more columns. 8, 9, 10. The probabilities are 0.10 varies for the, because it's saying each inter-arrival time has the same probability of occurrence. So it will be the same 0.10 and 0.10. I'll just copy. So cumulative probability is nothing but adding the next values. So whatever the previous values are there, we are going to add 0.10, 0.20, 0.30, so 0.40. So I'm just adding the previous value. So it's just easy to understand. So the range of the random numbers, it can start either from 0 or 1. So it all depends on you. So there is nothing criteria. So I will just start with 1. So 1 to 10. So the next number that is going to start is 11, because the cumulative probability is 10. So the next number that is going to start is after the ending of the first ending random number. The next random random number that is going to start is 11. And the cumulative probability for the 11 to 20, because the cumulative probability is 20, and 21 to 30, 31 to 40, so 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. So I'll just put 91 to, it's all 2 digits, so I'll just put 00, or you can put 100, no issues. And the next one is, let me just increase this one. Easy. Yeah, I'll just put it like this. I need one more table because I will have to. Yeah. I'll just highlight these values. Okay. Let us leave that part. And the next one is random service time and the probability. The service times are given 6, and the question they are asking, service time may vary from 1 to 6 minutes apart. So what I will do, I will draw one more table for the service. This is for the interarrival table, and I am just putting, and the next one is service time. So here also I need 4 columns and 6 rows. So I will just insert 4 columns and 6 rows. I'll add one more. I can add it here. So what is the service time? And I would say next one is a probability, and the next one same, cumulative probability. And the next one is range of the random numbers. I'll just increase the signed font size so that it will be easy. And yeah, so for service time 1, 2, 3, so it's all 1, 2, 3, 4, 5, and 6. And the table is 0.05, and you have to just see the probability of the service time. 0.05. The next one is 0.10 and 0.10, and the next one is 0.20 and 0.30, 0.20, 0.30, and 0.25 and 0.10, 25 and 0.10. And the cumulative probability is nothing but adding the previous value. So 0.05 plus 0.10, it becomes 0.15. 1 to 5, it should start with 6, 6 to 15, and it should start with the 16 to 35, 36 to 65, 65 to 90, 66 to 90, and it should start with 91 to 00. So these are the things. So next one is random digits are given, so I have to find out the range. From the range I have to put the time between arrivals. So I will add one more column here, one more table, random digits for arrivals, and I have to get the inter-arrival time. Time between arrivals is nothing but inter-arrival time. Inter-arrival time. So for the first one, it start with 0 always because it's inter-arrival time, the first customer. So 0. The next one is 72. 72 is in the range of 71 to 80, so it becomes 8. The next one is 15. It's in the range of 11 to 20. It's the second one. And the next one is 15, 94. So 94 is in the range of 94, 10th, because 91 to 00, it's the time between arrivals is 10. And the next one is 39. So 39, the range is 31 to 40, 4 minutes. Okay. The next one is I have to do the same thing. I have to insert a table for the service table also. So I'll put 2 columns. Just it will be easy. Yeah. And the service time. Random digits for the service time 84, 10, 74, 53, 70. So 84, the service time is it's in the range of 66 to 90. So 5, 10 for 10 minutes. It's in the range of 6 to 15. So it comes at 2. And 74. Just check this table. It's in the range of 66 to 90. So it comes at 5 minutes again. And 53. 53 lies in 36 to 65. It's 4 minutes. Just you have to check with this table, refer this table and add these columns in the other table, the random digits where it's coming, and just get the service time. 17, it's in the range of 16 to 35, it's 3. So now I have to find the average waiting time of customers, probability of a customer has to wait, and probability of server being idle. Now I have the inter-arrival time and the service time. So from these two, I can get the customers. The number of customers is 5 customers, he's saying in the question. So I have to create one single channel queuing table. So let me just draw the table with yeah. I will just put it here. Insert a table of I don't know how many, 5. So I put 6, maybe 10 rows, 10 columns. I'll just put. So first is customer. How many customers are coming? Next is inter arrival time. I will just inter arrival time, and here arrival time. I can get the from the inter arrival time I get the arrival time, and from here service time. And here time service begins, when the service is going to begin after the customer comes from the server, and time customer waits in queue, and time service ends. Time customer spends in the system. Next is the idle time of the server. And the time service ends is nothing but the departure time when the customer leaves from the when the customer leaves the when the customer leaves from the system. So he is saying 5 customers, 1, 2, 3, 4, 5, and the inter arrival times are given 5, 2, 5, 4, 3, 0, 8, 2, 10, 4. And the service times are given 5, 2, 5, 4, 3. So I have to get the inter arrival time. The arrival time 0. The next one is 8 minutes. Next one is 10. Next one is 8 plus 2 10, 10 plus 10 20. Next one is 24. And the time service begins is nothing but always the first customer begins with the, you have to check. So the time service begins, how we have to check is check, I'll just put it down here, that's better. Time service begins, check arrival time of current row and compare arrival time of current row, comma, time service ends I'll just put TS, time service ends TSC of previous row. Whichever is greater, keep the greater value. Okay. So first one, it always begins with 0. Time customer waits in the queue is nothing but time service begins minus arrival time. So I'll just add one more. So I'll just highlight this part. Time, I'll just put short form, time customer waits in queue is this one. This column is nothing but TSB, time service begins minus arrival time. And the next one, time service ends is equal to this one is nothing but time service begins TSB plus service time, TSB plus service time, and time customer spends in the system, time service time customer spends in the system equal to TSE minus arrival time, and the idle time of the server is compare time service begins, no, you have to difference of TSE TSB minus TSB of previous value minus TSE of current value. TSB of it should be current value minus TSB of TSE of previous value. When you are solving the problem, it will be easy to understand these things. Just in order to make it easy, I'll just put these values, previous value. Yeah, I'll just put it in. So it will be easy. So time customer waits in the queue is nothing but TSB minus 80, 0. Time service ends is nothing but service time plus begins, it's 5. Time customer spends in the system is nothing but TSB minus arrival time, it's 5. So first customer idle time will be 0 because he's starting at the 0. And the next one is time service begins. You have to compare the arrival time, this one, with the time service ends. Whichever compare arrival time of current row and TSE, time service ends. So I'll just put in the columns TSE, and time customer waits in the queue, it's TCW queue. Time service begins TSB. Time customer spends in the system and the idle time of the server. ITS. Yeah. So it will be easy. So time service begins, compare the time service ends 5 and 8. So 8 is bigger. So it's 8. Time customer waits in the queue. Time service begins minus arrival time. It's 0. Time service ends. Service time plus time service begins. It's 10. Time customer ends in the spends in the system 10 minus arrival time. Time service ends minus arrival time. It's 2. And the ideal time of the server, so you have to differentiate from time service begins of the current row. Current value is 8 in this row. 8 minus time service ends 5. 8 minus 5 is 3. The next one is time service begins. Just compare time service ends 10 and 10 arrival time. So both are coming at the same time. So it's same. And time customer waits in the queue. Time service begins minus arrival time. It's 0. And time service ends is nothing but time service begins plus service time. It's 15. And time customer spends in the system is nothing but time service ends minus arrival time. 15 minus 10, 5. Idle time of the server, compare the current value of the time service begins minus time service ends. It's 0. The next one is for the fourth customer, compare time service ends and the arrival time 20. 20 is greater. Compare the time service ends and the arrival time. So 20 is greater 20. Time customer waits in the queue is nothing but time service begins. Time service begins minus arrival time. So it's 20 minus 20, 10, 0. And time service ends is nothing but service time plus time service begins. It's 24. Time customer spends in the system is nothing but time service ends minus arrival time. 24 minus 24. And the idle time of the server is nothing but time service begins. Compare differentiate. A difference of 20 minus 15 is 5. And the next one is time service begins. So compare the time customer time service ends in the arrival time is same 24. Time customer waits in the queue is 0. And it's all zeros. Okay. And time service ends is nothing but it's service time plus time service begins 27. And time customer spends in the system, time service ends minus arrival time 27 is 3. And the idle time of the server is 3 plus 5, 8. Idle time of the server is nothing but TSB minus time customer time service ends. So it's nothing but 24, 0. Now we'll add one more column called total. Total customers is 5, and total inter-arrival time is 24. Arrival time also total value is 24, and service time plus 10, 12, 16, 19, and time customer waits in the queue 0. Time customer spends in the system is 10, 12, 16, 19, and 8. Yeah. So what I have to do here, calculate the average waiting time. So you know these formulas. I will just I'll just show you the formulas. It will be easy. So average waiting time is nothing but total waiting time by total number of customers. So total waiting time, average waiting time is time customer waits in the queue is 0 by total number of, it's always 0 because the next one is probability of a customer who has to wait. ends is I think at 27. So 8 divided by 27. So it's 0.2963. So that is what. So this is a kind of problem that we have to solve. I will show another type of problem how we can solve when they are not given any values. So this problem, I'll just increase the font size so that it will be better. Yeah, I'll just increase better like this. Yeah. Sure. Yeah, a small grocery store has one checkout counter. Customers arrive at the checkout counter at random times that range from 1 to 8 minutes apart. We assume that the inter-arrival times or so the service time is given. He is saying the customers arrives at the checkout counter at random times that range from 1 to 8 minutes apart. So they arrive at the counter at 1 to 8 minutes apart. We assume that the inter-arrival times are integer valued with each of the 8 values having equal probabilities following the uniform distribution, and the service times vary from 1 to 6 integers. And simulate the system for 10 customers, and they're given the inter-arrival times and the random, these are the random numbers, and we have to calculate the inter-arrival times and the service time. The service time probability table is given, but we have to calculate the service inter-arrival time probability table. So let me draw one more table here, the solution table here. It will be easy. And for calculating the different ranges, we can see here, let me just, yeah, there's a formulas are there. I know you are already seen in the textbook what are the average waiting time, total waiting time. So these are the 7 things that you have to keep in mind. How, if after calculating the, after drawing the table, you have to calculate whatever the things, whatever things they asked in the question, like average time between arrival, average waiting time. So these are all there. So let me go back again to, yeah. So insert a table. I want, I think so, 4 rows and 8. Yeah. So first one is having it's saying inter arrival times with each of the 8 values having equal probability. So with each of the 8 values, the first one it will be having 8 values, 1 divided by 8.125. The second one, it will be second, and it is saying the equal values. So it will be 1 divided by 8, and it will be having the same probability of occurrence. So 0.125, it will range from 0.125. So I can say inter arrival times and probability cumulative probability and what is the next one I have to do with each of the integer yeah, cumulative probabilities and the random range, obviously random range of the numbers. So I can say interarrival 1, 2, 3, 4, 5, 6, 7, 8, and the probabilities are ratioed as 0.125. So it will be the same. So you can see with each of the 8 values having equal probability. In the question it is saying equal probability. So cumulative probability 125, 0.250, 625, and 0.250. 750.875 and it's 1.00. Random range, it's in the 3 digits format, so it will be like 0 to, you can start from 1. I will just start from 1 to 125 and 126 to 250, 251 to 375, 376 to 500, 501 to 625, 626 to 750, 751 to 875, 876 to 310. You can put 1000 or something like that. So now we have got the inter-arrival time and the service time also. So you can calculate for the 10. Now you can see the inter-arrival times always start with 0 because here 9 numbers are only given. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can able to calculate, and you have to draw the simulation table, simulate the system for 10 customers and compute the average waiting time and the total time spent by a customer and idle time. You know the formulas, all the formulas, so you can just calculate by using these things. And that is what the single channel queuing channel queuing problems are about. And if you do have any kind of questions or concerns, please do comment in the below video. And I hope you got some basic understanding on single channel queuing problem, how to calibrate the probabilities and the random number generators, and how to calculate the formulas and the time service spent by the system, the random digits, and time service, time customer waits in the queue, time customer spends in the system, time customer ends, time service ends, and the idle time of the server. So this should be pretty much have basic understanding on this one. And thank you for watching the video. Have a nice day. Take care. We'll try to see this problem. A small grocery store has one checkout counter. Customers arrive at the checkout counter at random times that range from 1 to 8 minutes apart, and we assume that the inter-arrival times are integer valued. So as I said in the previous one, the inter-arrival times are 1 to 8 minutes apart. So we have to divide, and we assume that the inter-arrival times are integer valued with 8 of the values having equal probabilities. So the first probability will be 1 divided by 8, and the second one having equal probability. So I just assume that it will be an equal, so it will be 1 divided by 8, it is equal to 0.125, and there are 8 customers are there, like you can see here, as one checkout customer, and they are arriving at 1 to 8 minutes apart, and these are the values that has given. And I think so not 8 customers arrive at 1 to 8 minutes, service time spent. Simulate the table for 10 customers. So I have to simulate the table for 10 customers and compute the waiting time for total time spent by the customer. So the first one is inter-arrival time, the 1 to 8 minutes apart, and the probability and the cumulative probability, you have to just add these values, and the random interval range, like the 3 digits, the random interval range. And the service timetable is given, service probability, you have to calculate the cumulative probability and the random numbers. Then I have to map these values. Random numbers that have been given in the question are starting from 913, but if you see the given numbers are only 9 values, because the inter-arrival time for the 10 customers, first customer always starts with the 0, so you have to assume that it starts with 0, and the 0 lies in the interval range of in the 0. And 913 where it's lying, so you have to just check out this table where it's lying down. It belongs to the inter-arrival time at 8. So just map all these values, and you have to just put in these values. I have to, what is the question they have like asking? Simulate the table for 10 customers and compute the waiting time, total time spent by customer, and the idle time of the server. So I have to just calculate these values. So I'll just put out these values, and now what I have to do, I will just copy these values, inter-arrival time, service time, all these things, and I'll just put it here, the interarrival time. I'll just put it manually because it's not copying. So the customers are 10, 1, and I have to calculate the total values also. So I'll just add one more row. So it's a total, and the interarrival times are 0, 8, 6, 1, 6, 1, 8, 3, 8, 7, 2, and 3. And the arrival time and service time I have to just put whatever the values I got it from the random interval range 414324. 4, 3, 2, 4, 5, 4, 5, 3. And the arrival time to calculate these ones is just by adding the interarrival time, I will get the arrival time. The first one will be 0. I'll just put in these columns like 8, second one 0 plus 8, the previous one and the next one, and I have to just add this, keep on adding these values. 6, 14, 15, plus 8, 23, 26, 26, 34, 34, 41, 43, and 46. So these are the arrival times and the service times. And the time service begins is nothing but I'll just keep this formula. I'll just keep it simple. So it will be A, B, C, D, H. So time service begins is nothing but I have to just compare time service ends of the previous one, and so maximum of f it should be f previous one f I minus 1 my comma, and I have to compare with the arrival time. I have to compare and get the greater value. So maximum value of f I minus 1 and b I. It should be b I. Yeah. And the time customer waits in the queue is nothing but time service begins minus arrival time. So it's nothing but t minus b. So I'll just increase the font so that it will be closer to you. Yeah. So this is the time customer waits in the queue, and this is the time service ends, the greater value between the time service ends and the arrival time, and the time service ends of the previous row and the time service arrival time of the current row. Once if we solve, we will try to understand. So it will be, I will just change the color. And time service ends is nothing but it's service time plus time service begins. Time service begins. And Z is nothing but time customer spends in the system is nothing but F time service ends, F minus arrival time, F minus B. And the idle time of the server is nothing but, so it's nothing but time service begins minus time service ends. So it's nothing but of the time service begins of the next row, I mean I, and the time service ends of the previous one. So I can say it's D. I'll just increase this sizes. I'll just put it later. I'll just so it's D I So it's nothing but di minus time service ends fi minus 1. So it's fi minus 1. Okay. Okay. Now time service begins of the first customer will be 0 because the inter-arrival time is 0 and there is no time customer max of time service ends. And time customer waits in the queue is nothing but D minus B. So it's D is 0 minus B. So 0. Time service ends, service time plus time service begins, it's 4. Time customer spends in the system is nothing but time service ends minus arrival time, it's 4. Idle time of the server because there is nothing, time service begins, it's nothing, 0. So the next one, for the time service begins, you have to compare the time service ends of the previous one. So it's a fi minus 1, so the previous one and the current value, arrival time, fi minus 1 bi. So it will be 8 will be greater, so compare 8 and 4, 8 will be greater. Time customer waits in the queue is nothing but d minus b, it's 0. Time service ends, it's nothing but st plus time service begins 9, 8 plus 1. Time customer spends in the system is nothing but time service ends minus arrival time, 9 minus 8, 1. And the idle time of the server is nothing but time service begins minus time service ends, di minus fi minus 1, 8 minus 4, it's 4. And the next one, time service begins is nothing but compare the time service ends and the arrival time. Arrival time is 14 and 9, it should be 14 maximum value. Time customer waits in the queue is nothing but time service begins minus the arrival time, so it's 0. And time service ends is nothing but service time plus time service begins, it's 14 plus 4, 18. And time customer spends in the system is 18, 18 minus arrival time, so it's 18 minus 14, 4. And idle time of the server is nothing but 14, time service begins minus time service ends of the previous row, 14 minus 9, 5. And now compare the time service begins of the time service ends and the arrival time, 18 is greater, so just put 18. And the time customer waits in the queue is nothing but time service begins minus the arrival time, it's 3. And time service ends is nothing but service time plus 1, this one. And time customer spends in the system 21 minus arrival time, so time service ends by the arrival time, 15. So we understand this thing, so it's like 21 minus 15, 6. And idle time of the server 18 minus 18, 0. Same thing, you're just putting time service ends 21 and here the arrival time is 23. So the maximum value of 21 and 23 is 23. And here the time customer waits in the queue is nothing but d minus b. So it's 23 minus 23, 0. And the time service ends is nothing but 23 service time plus time service begins is 25. And time customer spends in the system is nothing but time service ends minus the arrival time, 25 minus 23, 2. And the idle time of the server is nothing but begins minus ends. Time service begins is 23 minus 21 of the previous row, so it's 2. And the next one is compare the time service ends the arrival time. Is 25 and 26 is nothing but 26, the highest value. And the time customer waits in the queue is 26 minus time service begins minus arrival time, it's 0. And time service ends is 26 plus 4, 30. And time customer waits in the queue 30 minus 26, it's 4. And the idle time of the server is 26 minus 25, 1. And next compare 30 and 34, the maximum value is 34. And time customer waits in the queue is nothing but d minus b, so it's d is time service begins minus the arrival time, it's 0. And the time service ends is nothing but st plus tsb, so the service time plus tsb, it's 39. And time customers ends in the system is f minus b, so it's 39 minus 34, it's 5. And the idle time of the server is nothing but 34 minus 30, it's 4. And for the eighth one, so compare the 39 and the arrival time of the next one, 41. The maximum value is 41 and the time customer waits in the queue is D minus B. So 41 minus 41 0, and the service time plus time service begins, it's 45. Time customer spends in the system is F minus B, it's 45 minus arrival time, 45 minus 41, it's 4. And the idle time of the server is 41 minus 39, it's 2. Yeah, and the next one is 45 and 43, the time service. So for the ninth customer, what we have to do is we have to calculate the time service begins. The time service begins is nothing but compare the time service begins 45 and 43. So it's 45 it comes, and the time customer waits in the queue is 45 minus 43, it's 2. And time service begins is service time plus time service begins, it's 50. And time customer spends in the system is nothing but how much is the total time spent, it's F minus B, so it's nothing but time service begins minus arrival time, it's 2. And the idle time of the server is 45 minus time service 0. The next one is 50 and 46. The highest value is 50. So compare the time service begins and the arrival time. And the next one is time customer waits in the queue is nothing but is 50 minus 46, 4. Time service ends is 53. Service time plus time service begins. And time customer spends in the system 53 minus 46, it's 7. And idle time of the server is nothing but time service begins minus the previous 50 minus 50, 0. So now we have to just calculate the total of everything. So it's service plus 5, 9, 12, 14, 18, 27, 30, 35. And the time customer waits in the queue is 3, 9. I hope so. 9. 39, and the idle time of the server is 18. So these are the values I got. So in the question, what are the things that is asking is like what is the compute the waiting time of the customer. So the waiting time, total time customer waits in the queue is 9. So average waiting time will be that total time customer waits in the queue by total number of customers. So there are some formulas are there. You have to just make sure that you understand. So average waiting time is total time customer waits in the queue divided by total number of customers. So these are the pretty much there in the, so you can just calculate with the help of those tables. And I hope so this is quite understanding for you. I mean, how to calculate the time service, how to calculate from the given random numbers from the given probabilities. First, you have to just arrange the interarrival times and the probability equally wise, because based on the question they are saying 1 to 8 minutes apart having equal probability. So you have to divide 1 divided by 8 into 8 equal parts. So you have 8 interarrival times 1 to 8 minutes, and you have to divide the probability into 8 equal occurrences, and make sure that you calculate the cumulative probability and the random interval range. And then from the given random numbers you have to make sure where its interval range is mapping, where it is lying down. So just make sure that you add so based on the question just calculate the values. And I hope so this is quite understanding for you in order to solve this kind of single channel queuing problem. And do let me know if you have any kind of questions or comments. Just post it in the description of the video. Have a nice day. Take care.